Alright, I want to document all my progress to my cell as of this point. You can see my setup here. We'll just kind of outline what's what. We've got a standard PC type power supply, 12 volt 2 amp. You can see those wires go to here, to a Molex connection. Go to my controller box. Nothing really special in here, just a couple switches, wiring. This is our pulse generator. We'll turn that on here. You can see that we're at 50% duty cycle and 374 hertz. That goes out to our MOSFET, which is mounted on this CPU heatsink. Goes to our high voltage transformer. This is a audio transformer, I believe. Takes 115 down to 12. We have it reversed, actually. It's taking 12 up to about 115. Goes to our diode here. This is a high voltage diode, specifically one that Stan Myers had picked out. To our coils here. Each one of these coils, as it sits on this standard E-core, there's a razor blade for reference, about 8 millihenries each. With this thing on it completed, it was, I believe, around 600, so like that it's 8. To our cell, this is our 6 cell 4-inch it wired in series. This is our amp meter for what our transformer and cell is pulling. This is the voltage across the cell. We're going to fire this thing on. Look at our production on this beauty. And once all the cells get going, you can see it just pours off of these cells. I am at 374 hertz, 50% duty cycle, consuming approximately 2.2 amps. That's on 12 volts. I'm consuming 12 volts, 2 amps. Our voltage across the cell currently is 21.25, which is one of the highest voltages I've been able to achieve across the cell. At any rate, look at this phenomenal production, 2 amps with our Stan Myers configuration. We are going to encapsulate each one of these cells in a insulative tube of some sort, and we're going to see what our production can go to there.
In this series of videos, I document my progress on unlocking the secrets of Stanley A. Meyer. For over a decade, I've studied and replicated the devices of Stanley Meyer, specifically the water fuel cell, a device that splits water into hydrogen and oxygen for use as a combustible fuel. Here, I discuss water fuel cell theory in hopes of connecting with other like-minded individuals to unlock the secrets. This is Stan's Revenge.
Watch this production. Just pours off of this. This is my 4-inch, 6-inch cell. Got these 2 inductors over this E-core. They measure, I think, 8 milliFarads. Milli. High voltage transformer. This is a high voltage diode. At 12 volts, we're consuming 2.1 amps. Across the cell, we have 23 volts. And this is quite, I believe, an efficient setup here. We're currently running 474 hertz, 50% duty cycle, and we are just pouring hydrogen off of that. Ordinary tap water. This is actually spring water. It's out of the bottle. Purified spring water. And again, our two chokes. One on the positive side, one on the negative side. I believe they're 8 some millifarads, MF, not UF, MF. High voltage diode, just per Stan Meyer's config. These are individually insulated cells. I don't know if you can see the tubing I slid over them. That bumped us up by a few volts across the cell. Didn't really help too much with amp consumption, but did produce a higher voltage across the cell. Now, if my math is correct, let's say we're 24, 25 volts, let's say, across the cell, and this machine consumes about 25 watts, let's say. That's less than 1 amp across these cells. So 1 amp at 23 volts is what that would account to. Love just seeing that stuff boil off of there. Test of perhaps how many liters per minute we're creating here. What I want to do is create more of these cells and wire them in parallel, and do a test to see how many amps we draw as we start adding these in parallel. Alright, final results for the night. I'm back to my 12 volt power supply coming in here. Same kind of setup here as previously. The only difference is we've got a diode, regular diode there. We've got a diode going into the cell. We've got a diode coming out of the cell. And then, interestingly enough, we have a diode connecting the south end of this one with the north end or positive end of that one. The high power transformer splits to here. This is the negative, this is the positive. So actually the negative going to the positive. So it's actually creating like maybe a feedback loop of some sort, but I'm able to get voltage up extremely high with these series of 4 diodes. One going into the cell, one coming out of the cell, one coming from the high voltage transformer, and one looping the south end or negative end of this inductor to the other inductors. Watch this puppy. I mean, that is just jetting off of that. Absolute bubbling, frothing, extreme production. 1.4 amps. We're talking less than 18 watts of consumed power. Over 27 volts at the cell. So that's 0.6 amps going through this cell. So we clearly have more voltage than amperage here. Yeehaw.
This is Stan's Revenge.